Welcome to the Make course. I'm Rudi Schlaf. This video is about controlling DC motors with the Arduino. I'll discuss how DC motors work, then how one can use an H-bridge circuit to control a DC motor. I will discuss the L298 integrated circuit that is used on these motor driver boards that you can buy for a few dollars on eBay and that work very nicely. I will also discuss how to write a sketch on the Arduino that controls this board. Let's first have a quick look at magnetism and magnetic forces. You probably all know that if you have a magnet, you have a north and a south pole, and if you bring magnets in close contact, then you know that north and south poles attract each other, and same poles, they repulse each other. And so that can be used to make a motor. But in a motor we need one more thing. We need a stator or a rotor where we can control the orientation of the magnetic field, and that is done by using a coil. And so if you have a coil, simply a wire wrapped around a piece of metal, then if you pass a current through the wire, you can make a magnet exactly like a permanent magnet. And so depending on the direction of the current, you can have the north pole here and the south pole here, or if you reverse the current, it will be turned around and you have the south pole here and the north pole. If you want to know where north and south is, depending on the current direction, there is the so-called right-hand rule. And so if you grab the metal rod around which the wire is wrapped, then if your hand goes in the direction of the current, your thumb shows where the north pole is of that magnet. So this is called an electromagnet. This here would be a permanent magnet. Alright, this is all the physics we need to know at this point to understand DC motors. This here shows a very simple example of a so-called two-pole DC motor. It's called two-pole because we have two coils that are on the rotor. This motor has a severe disadvantage because sometimes it doesn't start rotating by itself when you turn on the power to it, and you will understand in a minute why that is the case. So motors that you buy typically, they have at least 3 poles, which solves this problem. But to understand how the DC motor works, this is a really good example. Okay, we have here the rotor with the 2 coils, and then we have a stator that's on the outside here that is typically a permanent magnet, and you can simply think of this as a permanent magnet stick that has been bent into a circular shape. And so on one side here we have the north pole and on the other side the south pole. And so if we want to make this rotor rotate, all we have to do is apply a voltage to these coils. And if the polarity of the voltage is right, we can make a situation where we have here a north pole facing a south pole, and down here we have a south pole facing the north pole, and so these two attract each other and these two attract each other, and so we have a force that applies a torque on this rotor, and so we get a rotation started. Now the issue is, once we reach the horizontal here, these two forces essentially cancel each other, and then the rotation would stop in this motor. And so a DC motor like this needs a mechanism that reverses the polarity on the coils once the horizontal has been reached. And so for a very brief moment the voltage is turned off on the rotor to avoid a short circuit, and then it is reversed. And so once it is reversed, we have reversed polarity on the magnetic field on the rotor, and so we have a situation where now the upper coil is repelled by this north pole and the opposite coil is being repelled by the south pole, and so the motion keeps going, right? And typically this motor makes it across this brief moment when there is no power on the coil because there's some inertia in the mechanism, right? This is made from metal, and so once it moves, it keeps going, and so this brief moment here is being bridged by the inertia, and then the voltage turns around and the process continues. And now you of course immediately see why this motor once in a while doesn't start up. If you're unlucky when you apply power to the coils and the rotor is in this horizontal position, then there is no voltage on the coils, and so nothing happens. And so you would have to essentially grab the shaft and turn the motor a little bit, and then it would start rotating. So that's the reason why modern motors, they at least have 3 of these poles, and with that one can avoid this situation. So let's go real quick to this website where I took those pictures. They have a really nice animation, and so here you see it in action. So here now comes the switch point, and then we have repulsion and now attraction, and now it switches again, and so on and on and on the motor is rotating. Let's focus real quick on that switching process and how do the coils get the current in the first place. You probably wondered, because if we would just solder wires onto the rotor, then of course the wires would get twisted every time the rotor rotates one rotation, and so at some point the wires would of course break off because we would stretch them too much. And so the way we bring in the power to the coils is actually using brushes. So these are conductive brushes, and they connect to what they call the commutator. And so the commutator is mounted on the rotor. And so one of these contacts, so this one here, that would be connected to one end of these coils, and the other contact here is connected to the other end of the coils. And so you immediately see now, once this motor is turning 180 degrees, then the polarity reverses, right? This is where you connect your power source, your battery, right? Plus and minus. And so every time this turns 180 degrees, the polarity reverses on the coil. And so we get this mechanism that we need to keep the force in a way to make the motor rotate continuously. Okay, now you understand how a brushed DC motor works, and you probably also understand now that you can control the rotational direction by the polarity of the voltage that you apply to it. And so when it comes to controlling a brushed DC motor with a microcontroller like the Arduino, we need to find a way to reverse the polarity, because of course once you have a wired up circuit, you don't have somebody there who will disconnect the battery, reverse the leads and put it back on. You want to do this with the Arduino. What's often used for doing this is a H-bridge, and here you see an H-bridge in its schematic implementation. Essentially we have 4 switches, and these 4 switches connect the DC motor to the battery plus and the battery minus. And so you see immediately, if you close switch A and D, then you have plus on this side of the motor and minus on this side of the motor, right? So this is one polarity connection of the battery. And if you instead keep A and D open and you close B and C, then you reverse the polarity and the motor will rotate in the opposite direction. Now you could do this with relays, but of course in an electronic circuit we would do this with transistors. This here shows the probably most popular H-bridge configuration using 4 transistors. Here we have 2 PNP transistors as the 2 upper ones, and then the bottom ones here, they are NPN transistors. The reason for that is that depending on what we apply here, what voltage we apply to the inputs A and B, we want these 2 transistors to do the opposite, right? So there should always be one on and the other one off, or vice versa. And so this is what we achieve by using one PNP and an NPN transistor. Down here you see what happens depending on what we apply to these inputs. And so here we just have 0 and 1 on these inputs, but this means of course that 0 would be 0 volts and 1 would be a voltage that is VCC. If you think of it, what's happening, right? If we go here low on input A, then the NPN transistor is off and the PNP transistor is on, and so we have a current flow here into the motor. If we do the opposite on input B, right, if we set it high, then this transistor is on and this one is off, and so we get this one configuration where the current goes in from this side into this side and out into ground, and so we have one rotational direction of the motor, plus minus. And if we reverse the polarity on input A and input B, then we get the opposite situation where the current flows here from this side into the motor and then comes out on the left side here and goes into ground, and so we reverse the polarity with that. And so all we have to do now is essentially connect input A and input B to the Arduino in some way. It may be a little bit more complicated than just running this here into the Arduino. You may at least need a resistor here or even another transistor if the supply voltage here is higher than the 5 volts that is applied to the Arduino. Let's have a quick look at the L298 dual bridge driver integrated circuit that is on our motor driver board that we'll be using for the Arduino experiments. This chip, the L298, has two H bridges on it. This is a block diagram from the datasheet. So this is one of the H bridges, that's the other, and so you can actually run two motors with this motor driver board. So let's focus on one of the H bridges here. If you look closely, you will immediately see that this H bridge has 4 NPN transistors. So the upper ones are not PNP like in the previous example, but they're all the same. And that means we need to add some additional circuitry, because if you recall from the previous slide, these transistors need to behave opposite depending on the control input state, whether it's high or low. And so if they're both the same, they will of course do the same thing if we just would apply the input 1 signal to them. And so what we need is a NOT gate that reverses the input signal, right? So if we put here 5 volts, then we want that this transistor gets 0 and this one here gets actually the 5 volts. If we wouldn't have the enable inputs, the ENA and ENB for the two motors, we could actually get away by simply putting a NOT gate in front of the base of this lower NPN transistor, and then this would work again, even though the transistors are the same. But since we have the enable inputs, they also added these two AND gates, and you see here the AND gates, one of the input of each are connected to the enable line. That has the consequence that the signal from the input 1 can only get through to the bases of these transistors if the enable input is high, if we have 5 volts on it, right? Because then these two inputs of the AND gates are high, and if we apply a high signal here, then it can get through the AND gate. If one of them is low, then it doesn't get through. So by putting the enable input low, then that disables the inputs, and with this we can sort of shut down the motor regardless what's happening on the inputs. So that's an additional feature on this chip, and that's why we have these AND gates here. But otherwise, this is just an H bridge where we connect the motor and we have these two inputs, and depending on the polarity on these two inputs, whether this one is 5 volts or this one and the other one is 0 at the same time, the motor will go in one direction or the other. So it's very much like on the previous schematic. Okay, let's have some fun. I made a simulation of the L298 H-bridge driver chip, at least the one half of it. This was done in iCircuit. If you're interested in the software, you can go to iCircuit app. It's really a great piece of software, costs just a few dollars, drag and drop, real-time simulation. It's pretty awesome to do some quick and dirty simulations of simple circuits like this one. This just took me a few minutes to whip up, and then one can play with it. So here we have the H-bridge, the motor, the AND gates, the NOT gate, and these are the inputs. And so here's input 1, input 2, and enable. And these inputs, they are simulated by switches that have pull-up resistors. So if the switch is open, then we connect to 5 volts because there's very little current flowing into these gates. Hardly any voltage is dropping across the resistor, and so we have here 5 volts at the gate. If we close the switch, and let me turn on the simulation here, then you see here that now we have a dark color. This means we have a ground connection, right? So it's short-circuited. So if I open the switch, then we have 5 volts here, it's green. If I close it, then we have 0 volts. So with this switch I can simply simulate the Arduino putting these inputs high and low. And so what you see now is no matter what I do with these switches, nothing is happening with the motor. It doesn't rotate because the enable switch here is on 0, right? Because it's closed. So let's see what happens when I open the enable switch. And when I open the enable switch, what we get here is that the motor starts rotating. And actually we can click here on the motor and we can see over here that it right now would rotate at minus 137.399 RPM. So this is a certain motor that is simulated here. Well, if we want to change the rotational direction of this motor now, right, if we want to make it counterclockwise, so all we need to do now is reverse these two input signals, and you see now it's going in the other direction and the rotation now is positive, right? So this is how this software here thinks about rotation, plus or minus, depending on clockwise or counterclockwise. And if I turn enable on again, then the motor is dead. And so this is basically what the chip does. So if we want to use this chip, On our motor driver board, it's really simple. We hook up everything to power, and then we use the Arduino to control these two inputs and potentially the enable input if we like to. If we not, then we can just leave it open, and we can actually use these two inputs just to control motor on, off, and reverse. Because if both are closed, see, the motor is not turning either. So if we open this one, it's going backwards. If we open this one, it's going forward. So on the motor driver board, one can actually set a jumper that always makes sure that we have 5 volts on these AND gates, and then we can just use these 2 pins to control the motor. So with 2 pins, we can fully control this motor. Pretty awesome. And finally, here we go. This is our motor driver board. This is available on eBay for a few dollars, and I think it's a pretty neat little design. What I like about this board is that it has a heatsink on which the driver chip is mounted, and so that means you can really use this to the limit of the integrated circuit. So if it gets pretty hot here, then you know that you are stressing the circuit a little bit. Anyway, let's look what's on this board. We have these inputs, right? So these are the control pins. If you look here at their labels, so this is enable A and input 1 and input 2. So this is for one motor, the inputs, and then here we have the inputs for the second motor, input 3 and input 4 and enable B. The blue terminals here, they are used to connect the motor. So this is motor A that's connected with these inputs, controlled with these inputs, and then here we have motor B that's controlled with these inputs. You also see here these 2 jumpers, right? So they are here and here. They connect these enable inputs to 5 volts. And so this is what I just said when I talked about the simulation. As long as you leave these jumpers in here, the motor can be controlled just with the input pins. If you take off the jumper, then you can connect this pin to the Arduino and then use the enable input to do some master control of these motors. Now these 3 terminals, they are the power connections. So here we have, of course, the ground connection. This one always needs to be connected to the Arduino, otherwise you couldn't use these control pins because that's the reference of this board, and of course that needs to be common grounded with the Arduino Uno board or whatever other board you use. Then we have here 12 volts and 5 volts. And the 12 volt input, that is the input that is powering the motors. So typically you use a different power source for the motor because the Arduino board can only supply a few hundred milliamps. I wouldn't go higher than 300 milliamps. And for a motor, that's very little current. And so typically you connect your battery here that drives the motor, and then you would power the logic part of the integrated circuit with 5 volts from the Arduino. However, this nifty little board has a onboard 5 volts regulator. It's this package. And this regulator is actually connected here via this jumper to the 12 volts line. And so when you have the jumper in place here, the 12 volts also connect to this regulator, and then it makes you 5 volts. And that powers the logic circuitry on the L298 chip. And so as long as this jumper here is in place, you don't have to connect to the Arduino 5 volts. So that's pretty nifty. But there is one thing to keep in mind. If you use a voltage that's higher than 12 volts, then this jumper needs to go because the voltage regulator apparently cannot take more than 12 volts on this board. And so in that case, if your motor would run at 46 volts, for example, which is the maximum voltage that the L298 can handle, then you would have to connect here to the Arduino 5 volts output. What we also have here are these flyback diodes. So there are 4 for each motor. And these flyback diodes, they are essentially parallel to the collector-emitter connections of the transistors that are on the L298 bridge driver. They serve the purpose to save these transistors from voltage spikes that can come from the motor when you cut the power. When the magnetic field collapses in the coils, then typically a big voltage spike occurs, and that can fry the transistors that are on this integrated circuit. And this is where these diodes go. So I prepared that diode already, and so now you see how easy it is to make a circuit in iCircuit. So they sit here simply shortcutting these 4 transistors, but of course they need to be oriented against the voltage that is applied. And so when the motor now puts out a reverse voltage that would drive the current up here, then the current would flow through the diodes instead of being banged through the transistors, and so that saves the transistors from these voltage spikes. Okay, time to play. Let's have a look at the setup. Now this here is our L298 driver board, and here's the Arduino Uno. I selected one that has male and female headers. That makes it convenient because we can use one of those ribbon cables to directly connect the inputs here with the Arduino pins. This here is the grounding lead that goes from the Arduino ground to the grounding terminal of the L298 board, and then we connect the battery here to the external power input, which is labeled 12 volts and ground on the L298 board. And so the negative lead of the battery pack goes into the ground connection, and the positive lead of the battery pack goes into the 12 volts labeled connection. Of course, here the battery pack is only 6 volts, but this is only a 6 volt motor, and so this is perfect. Now the motor is just connected with 2 jumper wires that are soldered onto the motor terminals, and then here clamped into these motor terminals. If you wanted to run a second motor, you would simply connect it on this side here to those motor B terminals. Here's a detailed shot. This here are the 2 battery cables, right? So the red one goes into 12 volts, the black one into the ground terminal, and the ground terminal is also connected to a ground pin on the Arduino. This here is the ribbon cable that goes to the Arduino, and that connects the input 1 and input 2 for the motor that is connected here on this side. This here shows the hookup on the Arduino side in detail. This here is the ground connection, so that needs to go in one of those pins that are labeled G and D on the Arduino. And these here are the connections to the L298 inputs, and so we're using input 1 and 2, and these are the black and red jumpers, and they go here into 6 and 5 pins on the Arduino. One more thing, as soon as you connect the battery to this board, then a little bit of current will flow. And so it's a great idea to turn off the motor power by extracting one of the batteries that breaks the circuit here. And so you simply pop this battery back in when you're ready to drive the motor. The last thing we need to discuss before we can fire up the motor is the Arduino Sketch. As usual, I start out with a description of the hardware setup. That's a great idea in case you revisit your Sketch in half a year. And so this here will get you up to speed very quickly. The sketch itself, I start out with 2 pre-compiled define statements where I define the pin numbers that we're using. So the input 1 on the L298 board is pin 5 on the Arduino, and input 2 is pin 6 on the Arduino. And then in this very simple sketch, I don't even use a loop. All we do is here in the setup is define the pin modes of pins 5 and 6 here in 1 and in 2 as outputs. And then we digital write one of them low and the other one high. And at that point, the motor starts running. And that's about it. So let's put this to the test. Let's upload. Okay, now you just saw how we can turn the motor on. Well, it's also interesting to know how to turn it off. So let's do here a delay. And let's say we run it for 2 seconds, so 2000 milliseconds. And now we write here digital write input to low. So it's convenient to do this with copy paste. And so now the motor will turn on, run for 2 seconds, and then the motor will turn off. So when both of the inputs are low, then the motor is off. And so this allows you to turn the motor on and off as you want in your Arduino Sketch. Okay, let's upload it. Okay, so how about turning on the motor in reverse direction? So that's done very easily. Let's just put in here another delay for 2 seconds and then put in a digital write for input 1 that sets it high. And so in this condition now we have input 2 low and input 1 high. And you see that's the opposite from our initial start position where the motor turned forward, let's say. So here now with the low and high conditions reversed on the two inputs, we will get the motor to run in the opposite direction. And so of course we don't want to empty out the battery, so let's put another delay here in for 2 seconds so we can marvel at it going in the reverse direction, and then we write the input 1 low again. So in that point then we have input 2 and input 1 low, and so the motor should be off again. So let's see how this works and upload it. Alright, forward, brake, and backward. Okay, now we know how to turn the motor on and off and reverse its direction. Now, wouldn't it be great if we could also change the speed at which it's turning? And it turns out that this is surprisingly simple with the Arduino, and we don't have to change anything with the hardware. We just need to change our code a little bit. Now, the Arduino has several digital pins that are so-called pulse width modulated ports. And so 5 and 6, the ones that we're using, they are pulse width modulated. And so what I'm explaining here can be done with these pins. And so pulse width modulation means that the pin isn't just on or off. We can set it to be on for short periods of time and then off in between. And so the time it's on, that is the so-called duty cycle. So here this shows a 25% duty cycle. So for a given time, it is 25% of the time on and 75% of the time off. And so we have other duty cycles, of course. We can set them in 255 steps. So you could easily go to a 35% duty cycle or a 51% duty cycle. So you get the idea. Now pins 5 and 6, they do this at 980 Hertz. So this here occurs at 980 Hertz, so 980 times per second. So that's really fast. And that means when we put this signal into the motor driver chip, the L298, then we will not notice that the motor is turned on and off very rapidly because the motor has inertia. But what we will notice is if we go to a smaller duty cycle, the motor will simply go slower. And that allows us to pretty much determine the speed at whatever level we want. Let's try it. Let's see what we need to change in the code. So let's go back to where we started by basically just turning the motor on. And this here would simply turn the motor on. And all we need to do now is if we want to run it at a slower speed, we need to replace that digital write with a analog write. Analog write. And then of course we cannot just say high or low. We need to actually give it how that duty cycle should be. So let's just go to 120. That's about half power. And let's see what happens now. And as promised, a much slower motor. Now I leave it to you to figure out how to turn it backwards slowly. It's pretty obvious, I think. You just need to use the other pin and put that pulse width modulated signal on that. This concludes our video about controlling DC motors with the Arduino. If you have some time, check out makecourse.com. There's a whole bunch of other videos that teach you how to do a lot of things with the Arduino. Thanks for watching.